Hello, everyone, and thank you for joining us for the Forestry Adaptation Practitioners Network webinar titled Climate Change Mitigation in Canada's Forest Product Sector, Roadmap Towards Net Zero. My name is Suzanne Sealing, and I'm the Community Manager of the Online Forestry Adaptation Practitioners Network. For those of you who aren't familiar, the Forestry Adaptation Practitioners Network is an online community for climate change adaptation in the forestry sector. It provides a space where researchers, experts, and practitioners can come together to communicate and share resources with others who are also working in the field of climate change adaptation. It has features like news, events, resources, and so much more. It's also free to join. I'll post a link to the network in the chat box. You're welcome to click on the link for more information and to become a member. Before we get started, I just have a couple of housekeeping items to go over. If at any time during the webinar you have questions or experience technical difficulties, click on the chat box, find my name in the drop-down menu, and you can send me a private direct message. I'll do my best to help you. We encourage you to use the Q&A box to enter any questions that you might have throughout the presentation. We will address these during the dedicated Q&A question and answer period at the end of the presentation. If you see a question that's already been entered, feel free to vote for it. I also would like to mention that we are recording the webinar today, and I'll be sending out a copy of the recording to all those who have pre-registered. It will also be posted to the FAPN website. With that said, we are very excited to have Sarah Falloon and Kate Lindsay here with us today. Just so you know a little bit more about your presenters, Kate Lindsay is Senior Vice President and Chief Sustainability Officer with the Forest Products Association of Canada, or FPAC. Kate is a wildlife biologist, has spent 20 years working in the field of species at risk recovery, sustainable resource development, and more recently on climate change mitigation and adaptation. Kate is responsible for working with FPAC members, partners, and governments to advance environmental and climate leadership files, as well as evidence-based federal policy. Kate's a member of the Nature Advisory Committee, the National Adaptation Strategy, Strong and Resilient Economies Roundtable, and a Canadian Fire Smart Advisory Committee member. We also have Sarah Falloon. She's a senior consultant at Delphi. At Delphi, she specializes in biodiversity and climate change mitigation strategies within the private sector. She brings a wide range of climate change and sustainability experience, including greenhouse gas accounting, agriculture, and forest sector emission reduction strategies, sustainability reporting, so much more. She has over 10 years of prior experience in forest management, silviculture, and GIS, and has worked both in private forestry consulting and government, primarily on the BC coast. She's a registered professional forester with the Forest Professionals of BC and is on the board of directors for the Cumberland Community Forest Society, a non-profit dedicated to forest conservation in and around her community of Cumberland, BC. So on behalf of everyone joining us, I would like to extend a very warm welcome to our presenters and thank you for taking the time to present with us today. Without further ado, I will turn things over to you, Kate.
Thank you, Suzanne. And just make sure you can hear me. Perfect. Yeah, thank you so much for the opportunity to join the session today. And I'm really happy to be here also with Sarah to present on the climate change mitigation in Canada's forest product sector roadmap toward net zero. So I'm just as a bit of an outline for today, I'll do a bit of a background, context, and initiation of the project. Then we'll turn things over to Sarah. And then I'll come back on to talk about action, implementation of the roadmap and next steps. And then we very much look forward to questions. So I will just preface this, but this is FPAC's perspective, you know, the initial context setting slides, and then we'll turn it over to Delphi. So just a way of introduction, FPAC, for those that are not familiar, we're based in Ottawa. We're the national voice of the forest product sector across Canada. We have members from coast to coast and members that manage forests, but also operate sawmills, pulp and paper mills, and bioenergy facilities. And so we've been working on climate change for some time now. And I've been at FPAC for over 10 years now. And we, in 2016, as a direct kind of response to the Paris Accord, UNFCCC COP meeting, which really set kind of that North Star for emissions reduction targets or global warming target. FPAC got together with members and experts, and we wanted to put forth a challenge for the industry to make further reductions in emissions and increased removals of carbon. And that was our 30 by 30 climate change challenge, and that was launched in 2016. And we really kind of appreciated that right before that in 2014, the Canadian government, Canadian Forest Service, had released a report around quantifying the biophysical climate change mitigation potential of Canada's forest sector. This is a report by Carolyn Smith et al. And it started to quantify how, managing forest, transition to long-lived wood products, different scenarios could take place across Canada, and what would the mitigation potential be over time? And obviously, for those mitigation options to be realized, action needed to take place as soon as possible. And so one of the, the better performing portfolios, the long-term portfolio, we estimated, got to about 22.9, 23 to 25 megaton gain or reduction in emissions. That we kind of took that 25 megaton number and we added to it. We thought we could try to be a bit more ambitious. And again, this is meant to be a stretch target for Canada's forest sector. Again, just a bit of context. We are really fortunate to have an excellent technical research group in Canada called NCASI, the National Council for Air and Stream Improvement, which has a lot of expertise in climate change and the pulp and paper sector in Canada. And so in 2021, NCASI also started to articulate the various pathways or opportunities for Canada's forest sector to decarbonize and contribute to GHG reduction. And so this is just an excellent graphic that they've put together that starts to talk about those different, I guess, portfolios or pathways. So around climate smart forestry, long-lived wood products, which lock up carbon, speaks to the GHG emissions that have already happened in Canada's forest product sector. So since 1990, there's already been significant reduction in emissions in our manufacturing sector, largely as a result of fuel switching, but lots of other optimized efficiencies in the manufacturing side of things. Optimal use of forest products. So there's ways in which forest products can be reused, and so that carbon stored can be kept out of the atmosphere. And then avoided emissions is that product substitution, or when a forest product can be substituted with another product that's more emission intensive to make. So this is NCASI's articulation. We also started to do some work. So essentially, we recognized we needed to shift a little bit away from the 30 by 30 challenge. It was still a really good challenge, but also there'd been a lot of changes globally around the language moving towards net zero, and how could Canada's forest products start to contribute to Canada's targets around emission reductions and net zero. So we looked at other strong forest countries, forestry jurisdictions globally, and in 2017, Finland had put forth, so the Finnish forest industry had put forth the green and vibrant economy. And we really we liked the way they had visualized the opportunities across the value chain. And it was something that we weren't seeing the Canadian government advance. And so we wanted to do some work to advance that full value chain solution of Canada's forest product sector. And so in Finland, they're also working within the Green Deal in the EU. So they which is a 2035 timeframe. So they wanted to quantify the emission reduction or increased removals of the forest from 2017 to 2035 across the forest products, their manufacturing plants, and logistics. So, and you can access that report at the link provided. So then we were in the stage of looking to do this quantification. We wanted to work with publicly available information. We have some expertise within our members and Cassie and FP Innovations and a number of technical experts, but we were looking to partner with a project management team that could help us frame this report, help with some of the technical expertise, and had some knowledge in doing this with other, either in other sectors or with other partners. So we were really pleased to be introduced to Delphi and their team of experts across Canada. And I would also say, just after we initiated the project, Sarah joined, and so it was great that Sarah is an RPF as well, so brings even extra level of expertise related to our sector. So in working with the project team at Delphi and FPAC, we just started to really, this is really kind of sketch out what are the options available? How do we incorporate the full value chain across the sector? And it really is this systems perspective that there are opportunities in the forest to reduce the release of GHGs. There's further opportunities at mills and facilities. There are opportunities across the transportation around modal shifts and electric logging trucks and these types of things. And then, of course, in the product space. So, what are the products where wood and forest products, bioenergy could be replacing or substituting fossil fuel derived or more emission intensive products across society. And then, of course, the end of life. So there's opportunities with wood products to reuse products to avoid landfilling them, and also for them to go into bioenergy at end of life. So just before I turn it over to Sarah, some of the, whenever you undertake a really large project like this, that's quite complex, there comes a time when you need to kind of make a decision on some things around scope and how you're going to approach what's included in the roadmap. So I just wanted to provide a bit of that context, some of the principles by which we approached this project. We did want to be very transparent about the information, where it comes from. We wanted to be inclusive of the full value chain as much as possible, both the emissions and removals. We also wanted to, when we got to kind of target setting for 2030, 2040, and 2050, we wanted it to be both feasible and ambitious. And so we worked across our members. So these are mill managers, chief foresters, ecologists, but also technical experts. So we want to acknowledge experts that were part of kind of an initial scoping team, both at Canadian Forest Service, Environment and Climate Change Canada, FP Innovations, Cassie, that could bring some of that expertise and almost act as a soundboard when we started to talk about the scope. And then later when we talked about those pathways that emerged, how feasible, if we, for instance, BECCS adoption, the bioeconomy, carbon capture and storage, the technology exists, but it hasn't been applied in Canada yet. What is the cost? How prohibitive is the cost to add those types of carbon capture capability at some craft mills across Canada? What's the storage? So those are the feasibility considerations that went into our conversations. And so Sarah can talk a little bit about how we address that with different scenarios. And then the scope, recognizing that there's emissions happening as a result of natural disturbance. There's product users, so customers, and then end of use of products that we as a forest sector don't necessarily have control over. So we did also want to scope what was in our direct control, but recognizing we have an opportunity to work across the value chain to implement change. We did also make a decision on forest carbon not to have a target related to increased removals or emission reductions, just given how vast the forest is in Canada. We only harvest and regenerate about 0.5% a year. So our actual control over that is somewhat limited. And so we wanted to be careful not to take on too much within the forest carbon side of things, also recognizing that it's very vulnerable. And almost case in point is how significant last year's fires were, unprecedented. So we did want to, where we talk about forest carbon and climate smart forestry, we preface that with an evidence-based approach, taking literature where forest carbon has been assessed across different countries and different types of forest management regimes. And then similarly with product substitution, there are no available data sets across Canada for when a forest product is used instead of, let's say, cement or steel in a building. But what we do have is real life case studies of buildings that have been built with wood or mass timber versus a conventional concrete and steel. And that's where we want to just demonstrate what is possible based on those real life buildings in Canada. So with that, that's a bit of some of the decision points that FBAC had to make going into this with experts. And I'm pleased to turn it over to Sarah to get into more of the project scope, methods and findings. Thank you. And just let me know when to advance, Sarah.
Yeah, you can go to the next slide. So as Kate mentioned, I'm going to go into the emissions profile for the forest product sector and the value chain that we developed and how it was developed and what's included in it. And then I'm going to go into the different emission reduction targets and pathways that we identified along the way. So next slide. So this is the emissions profile. The diagram that you see on the left here was developed to illustrate the different carbon emission and carbon removal, so carbon sequestration sources within the forest products value chain, the relative size to each other, and where the sector has control over reducing emissions versus only influence, and where collaboration with other sectors, consumers, and governments would be required. So before I dive into that, I just want to briefly touch on the managed forest and what we consider the managed forest in this scenario and in terms of accounting for carbon emissions and removals within forests. So in this context, the managed forest is considered to be under the influence of human activities. It could be harvesting, conservation, or fire management, regardless of whether active management is actually taking place. And this is aligned with how Canada accounts for and tracks carbon emissions and sequestration within its forests. So under this definition, approximately 65% of Canada's forests are considered managed. You can see in the diagram on the right, the dark green represents the managed forest, and the light green is the unmanaged forest. And so the back to the emissions profile. So the emission and removal sources of the forest product sector were placed into 4 different buckets and then placed on the horizontal line based on where they are in the value chain, upstream on the left and then downstream on the right. And then the light gray green bar on the bottom indicates the level of control that the sector has over each bucket. So I will start with natural disturbance, and this is within the managed forest only. So 170 million tons of emissions. This is a 2015 to 2020 average based on data from the Canadian Forest Service as reported in Canada's National GHG Inventory report that it uses to report its annual GHG emissions. And this represents direct and indirect emissions from wildfires, insect infestations, and also includes carbon sequestration from post-wildfire stand regeneration. So then I'll move into the light green bar, and you can see it's below the horizontal line, which means carbon removed from the atmosphere. And this is the sum of emissions and removals that happen within the managed forest. So carbon sequestered by trees growing, but also carbon released from decay. This includes that stands that were directly impacted by forest management activities such as harvesting, mature stands affected by natural disturbances that caused less than 20% mortality, mature stands that were affected by stand replacing natural disturbance in the past, but have reached commercial maturity, and also slash burning. Then moving into the direct control, this is operations, manufacturing, and transportation. So these are activities that are under direct control of the forest sector. Includes harvesting operations, transport from the forest to the mill and mill to the consumer, pulp and paper mill emissions, wood product mill emissions, and slash burning. And I know I just said slash burning was included under the managed for forest, but because that's how Canada accounts for the emissions associated with slash burning. But we also wanted to include it under direct control to illustrate and to highlight that those are emissions the forest sector can control. The data for transportation and operations was provided by FP Innovations and Natural Resources Canada, and mill emissions were from FPAC's Energy and Environment Mill surveys of pulp and paper and wood product mills. And then moving over to downstream, so product end of life disposal. So these emissions, 136 million tons annually, again, is a 2015 to 2020 average. This includes biomass burning, product decay in landfills. I also want to note, though, that methane emissions from when wood products, especially paper, are disposed of in landfills and decompose anaerobically. These are not included here. And that's because this is an area of active research, and there was no published data available to include that here. So I just wanted to note that. You can go to the next slide, Kate. So yeah, I'll just now talk about the emission reduction pathways and the targets for manufacturing operations and transportation, the managed forest and forest products. You can go to the next slide. So I'll start with manufacturing. The two main emission sources associated with manufacturing are fossil fuel combustion and electricity consumption. For fossil fuels, decarbonization relies on the phase out of heavy and light fuel oils, lime kiln decarbonization, fuel switching to biomass to eliminate natural gas, as well as optimization and energy efficiency improvements. The graph on the bottom here shows the emission reduction targets in the blue and teal relative to current emissions, the gray bar, for 2030, 2040, and 2050. So there's two target ranges based on two scenarios. This was an analysis done by FPAC. The midpoint scenario in the teal estimates emission reduction potential based on current policy climate and trends. And then the ideal scenario assumed supportive decarbonization policy and sufficient funding and represents what's theoretically possible. So as you can see, there's still residual emissions in 2050, even in the ideal scenario. This is because some fuels, such as light fuel oil and natural gas, will likely still be required to facilitate startups and shutdowns. So it's unlikely that they'll be eliminated completely. So the success of fossil fuel emission reductions in manufacturing requires strong government policy and support to enable the transition from fossil fuels to biomass. Also requires significant funding for research and development, as many of these technologies, such as limekiln decarbonization, are still in the early stages. And also steady access to biomass is required, and a recognition and support of biomass as a renewable fuel. And then for electricity consumption, the emission reduction targets shown here strongly depend on the decarbonization of Canada's electricity grid. And the targets here are estimated based on the targets in Canada's 2030 emission reduction plan, in which Canada is working towards a net zero electricity grid by 2035 and 88% reduction by 2030 from 2005 levels. Next slide. A decarbonization pathway both for the forest product sector and as well as more broadly across other sectors is the use of bioenergy with carbon capture, utilization, and storage, or BECCS. This is a process where the CO2 emitted from biomass generated bioenergy is captured and permanently stored or utilized as feedstock for other products. So the forest product sector generates over 31 million tons CO2 per year from biomass combustion, and applying BECCS to pulp mills and other facilities would allow those emissions to be pipelined into long-term geologic storage. So the forest product sector has an important role to play in BECCS implementation because it already has bioenergy facilities that could then be retrofitted to BECCS facilities. And then these facilities could serve as hubs that other operations nearby could also pipe their CO2 emissions to. So the graph on the right here shows the emission reduction potential of BECCS, estimated through an analysis done by FPAC using the same midpoint and ideal scenarios. So in both scenarios, it's not expected that BECCS facilities would be operational by 2030, but rapid adoption beyond then could result in substantial emission reductions, especially with the right policies and investments in place. So as you can see, BECCS shows promise in helping reduce emissions, but implementation still faces many challenges. There's still significant costs in retrofitting existing bioenergy facilities. The technology is still relatively new in Canada, so investment in research and development is required, as well as a sustainable supply of biomass is needed. Next slide. So now I'll touch on forest operations and transportation, and I'm going to talk about them together because their emission reduction pathways are similar. And then I'll touch on slash burning. So for transportation and operation, in the short term, the emission reduction pathways that we could implement now and in the near future include optimization, operating efficiencies, and hybrid technologies. So for example, a diesel engine supported by an electric engine. In the medium term, we would see the introduction of electrification and alternative fuels such as natural or liquid natural gas and biofuels, and also the continued use of hybrid technologies. And then in the long term, we'd see the widespread application of zero emission vehicles. Specific to transportation, also increasing rail transport substantially reduce emissions as transport by rail is more efficient than by road, especially if rail is electrified. So the graphs below illustrate high range and low range emission reduction targets relative to current emissions, both for operations on the left and then transportation on the right. These emission reduction estimates were provided by FP Innovations. And complete elimination of fossil fuels in transportation and operations poses many challenges still. And that's because the current technology, there's limits, reduced payload, there's also lack of infrastructure. We don't have charging stations in the forest. Forest operations happen a long ways away from mill. And then there's also significant costs. So, a lot more research and development, as well as investment would be required to implement these, especially electrification and alternative fuels at scale. And then in terms of slash burning, we could significantly reduce forest sector related emissions by eliminating slash burning. And this could be achieved through increasing utilization and then using residues for bioenergy and biofuels. Next slide. So as Kate mentioned earlier, in terms of emission reductions in forests, we took a slightly different approach and did not include a quantitative target due to the large amounts of uncertainty associated with climate change and impacts of natural disturbances. But we did identify a number of pathways to reduce emissions in our forests, enhance forest resilience, and improve carbon sequestration and storage. And these are key components of climate smart forestry and can be achieved through a number of forest management measures, some of which I'll go over on the slide here. So in terms of fuel management, we can do thinning and cultural burning to reduce risk of wildfire and wildfire severity. We can plant more mixed stands and increase species diversity to increase resilience against pests. When replanting, we can consider the future impacts of climate change, such as drought and wildfire, and plant more deciduous species to reduce wildfire risk. Conservation of old forests that are not in high disturbance risk areas is also part of climate smart forestry, as old forests can be large stores of carbon. Managing for a mosaic of forest stands, improving the management of protection of fire-prone forests, prioritizing the protection of peatlands as these are from wildfires, as these store large amounts of carbon that has been there for thousands of years. And then in terms of harvesting, so prioritizing harvesting of mature forests that are at a high risk of disturbance and already have low productivity. And then a second opportunity within forests is afforestation, which can have a significant climate change mitigation potential if implemented at scale. There was a study done in 2021 that estimated, this was for Canada, looking at natural climate solutions, and it estimated that implementing afforestation activities such as urban tree planting, silvopasture, restoration of forest cover could result in 460 million tons of emission reductions by 2050. So while afforestation is maybe not directly under the purview of the forest sector, the sector would be in a good position to support afforestation efforts across the country. Next slide. And so finally, products. So as Kate alluded to, we've identified a couple of different pathways, but again, did not set quantitative targets because estimating that is difficult and needs to look at systems approach. So like looking at the stock changes in the forest, tracking forest products all the way through to end of life, and then estimating substitution benefits. So the two pathways that we identified include substitution, so substituting forest products for other materials, such as concrete and steel that are more emissions intensive to produce. And then substituting biomass for fossil fuels could result in substantial emission reductions, especially if coupled with BECCS. And this could be a large decarbonization for other sectors as well, where the forest sector supplies the biomass to run processes that previously relied on fossil fuels, such as coal and natural gas. And then the second component is increasing carbon storage within products. And so long-lived wood products, such as those used in construction and mass timber, can store carbon for much longer than products such as paper and packaging. So shifting production to more long-lived wood products is an effective climate change mitigation strategy. And the second component is improving the recovery, recycling, and reuse of forest products is another way to extend the length of time that carbon is stored, and also reduces waste, keeps product out of landfills, and reduces production emissions. So ultimately, the shift towards a circular economy where forest products are continuously recovered, recycled, and reused before being burned to generate energy would maximize their carbon storage potential. Next slide. So to summarize, current annual emissions from direct operations, we estimate it to be around 20 million tons of CO2 equivalents annually. This includes manufacturing, transportation operations, so harvesting, silviculture activities, and slash burning. The other emissions and carbon removals in the value chain are not necessarily under direct control of the forest sector, but these need to be included and looked at from a systems approach, and that includes natural disturbance, the managed forest, and product use and disposal. And then opportunities for climate change mitigation lie within the entire forest products value chain, range from climate smart forestry practices, adoption of new technologies such as electrification, switching to more long-lived wood products, using biomass for energy, and enhancing product recovery, reuse, and recycling. So with looking at all that together, FPAC estimates that the sector could contribute 18 to 46 million tons of emission reductions annually by 2050. And that's all I have, so I'll pass it back to Kate.
Thanks, Sarah. So I'll go through maybe a couple of examples of where these pathways are starting to be implemented and where there are opportunities to scale up, kind of from a real life perspective. So as Sarah mentioned, kind of with a collection of those different pathways, but just wanted to include, this is available in the report, which is available on our website, and be happy to share the link with Suzanne. But you can see the manufacturing, the forest operations, and the transportation focus areas and pathways, as Sarah mentioned. And so really, like, one of those big opportunities for emission reductions, as well as negative emissions for the sector, is the adoption of BECCS. But as Sarah mentioned, there's a number of challenges to overcome. That said, it is being explored. Feasibility studies are being undertaken at a couple of facilities right now in Canada. The other I just wanted to highlight, and this link to this paper is included in the report as well, but it was hard for us to get at quantifying. So this actually, there's a question that came up around LULUCF. So this is a LULUCF study that was done across boreal countries that have boreal forests that engage in forest management. And so it demonstrates that the carbon stocks were increasing in jurisdictions that have more intensive forest management. Essentially, they're losing less carbon to fire and forest pests, and able to maintain carbon stocks and increase carbon stocks in those forests across different types of management. In Alaska, there's no forest management. In Canada, we practice low intensity forest management. And in the Nordic countries, they practice more high intensity forest management. So again, that's just an opportunity to see how other countries are practicing climate smart forestry on the ground. And this is just an example. So even within the managed forest in Canada, as per our reporting to IPCC, we include areas, so that map that Sarah showed earlier, areas where fire suppression is employed, areas that are includes protected areas, as well as areas that would be under forest management or under tenure for commercial management. And so on the left here is a picture of Jasper National Park. And so this is mountain pine beetle outbreak, and there's actually a great video from Parks Canada that kind of walks through how they tried to implement prescribed burns and ultimately got to a point where they needed to bring in a level of forest management just to create a fire break around the community. And then on the right is not far away from Jasper in the Boreal, where a forest management company, one of our members, has practiced ecosystem-based management, where we understand the high carbon stores within those wetland, peatland complexes, emulating natural disturbance design, but also increasing the resilience of that forest should a fire start in proximity to that area. So that's just visualizing that concept of climate smart forestry. And then in the report as well, we profile a few examples. So this is the Canadian Nuclear Laboratories in Chalk River, Ontario, which so a federal government building that has utilized mass timber from Nordic Structures, which Nordic Structures is a mass timber producer in Quebec, based out of Montreal. And so again, you can then go into a calculator, a carbon calculator, to assess how much embodied carbon is in this building versus what it had been if it was made with concrete and steel. Another case study we included in the report, this is the opportunity to make biofuels. So this is a plant, and its construction is underway. It's in Prince George in the Lete Dene First Nation in partnership. And it uses waste biomass from sawmills in proximity and creates a biodiesel that can then be used for transportation fuels, sustainable aviation fuels. So it lowers the carbon intensity of those fuels, which is great as far as growing the bioeconomy and utilizing some of that wood waste. And then the other case study contained in the report is essentially a carbon capture utilization project. This is a very large greenhouse that's been built in St. Félicien, Quebec, and the Resolute pulp mill is next door. Waste heat from the pulp mill is pumped into the greenhouse, so the greenhouse is able to use the waste heat from the mill, which reduces their use of fossil fuel to heat the greenhouse. In addition, there's a carbon capture technology that's just being kind of brought on board right now. So that Tundra greenhouse will, once it's up and running, will collect an additional 30 tons of CO2 per day from the pulp mill. So it's just a great example of carbon capture utilization, but also it's just a great example of food security and supporting the community locally. And I was really quite honored to have the opportunity to launch this report, kind of a soft launch at COP28 in Dubai at the end of 2023. And I was joined up on stage. So we presented at the Canadian Pavilion with Ara Erickson in the middle of that photo and Tina Rasmussen from Meadow Lake Tribal Council, just because these are two organizations that have really embodied aspects of the roadmap. Weyerhaeuser globally has their own commitments around carbon reduction, emission reductions. And Tina Rasmussen, Meadow Lake Tribal Council Industrial Investments, own a sawmill, largest Indigenous owned sawmill in North America. They have a 50% ownership in a forest management company, and they just commissioned 3 years ago a combined heat and power biomass facility. So they're utilizing the rest of that wood waste from the sawmill and creating energy to reduce the community's reliance on diesel. So just an excellent example of circularity, reduced waste, and bioenergy creation. Also at COP28, just because it's relevant as far as how our government's advancing on the commitment to decarbonize the built environment. And so we were really pleased in Dubai again, and Canada, you can see one of the countries that made this commitment. So this is a commitment to for greening construction with sustainable wood. So if wood is produced from sustainably managed forests, and we increase the use of wood in the built environment, we have that opportunity to reduce the embodied carbon in buildings, as well as ensure that climate smart forestry is taking place. So there's a win-win opportunity there. And I also just want to emphasize that when we look at at climate change and emission reductions, we don't do that without kind of looking at that holistic approach of landscape management, increasing the resilience. So, you know, Canada's forest sector is really, it has an opportunity, perhaps a unique opportunity across other economic sectors in Canada, in that we can take action on climate change and emission reductions. But while doing that, we can ensure biodiversity conservation, economic growth in rural communities. The procurement of wood, as I just mentioned, can help with the affordable housing crisis. We can also practice climate smart forestry and prioritize communities most at risk of wildfire and evacuation, and also doing this in partnership and inclusive knowledge systems and supporting Indigenous reconciliation, which we're seeing increasingly in Canada. So 135% increase since 2005 in the amount of Indigenous held tenure across Canada. And so what are some of the next steps? Again, this is from FPAC's perspective. We're really focused on kind of supporting wildland fire, energy transition, and the bioeconomy, as well as ongoing Indigenous reconciliation. But we're really pleased to have this report and the articulation of the pathways and opportunities and also the barriers that need to be overcome, so we can build awareness within government decision makers to find those full value solutions and that systems approach. We've been able to identify some enabling policy with the roadmap to really scale it up. You know, actually just last week, the federal government released its budget, and we're pleased to see that biomass is being included in the investment tax credit, so for those mills that could make an investment in the use of biomass to decarbonize, some of that enabling legislation will be there. We need to continue to find a market for low-grade wood, district heating systems, like even things outside of the forest product sector. But again, an opportunity to use that to further decarbonize. Some of that continued investment in research and development, as Sarah had mentioned. And then there are enabling policies just coming out of that commitment to decarbonize the built environment, is enabling policies around embodied carbon targets for the built environment. And that's where municipal governments can really take a leadership role in using wood. And then, of course, partnerships. So we appreciate having an opportunity to speak with you today and have these ongoing conversations about implementing the roadmap across the full value chain, recognizing that the forest sector, the industry itself, only has so much within our control, but there's some amazing kind of innovative organizations. One that I just came across recently, Unbuilders, which actually pull out wood components of buildings when they're being deconstructed, so they can be, if they're structurally sound, be reused in buildings. Again, that's holding that carbon locked in that wood product for even longer and avoiding it being landfilled. It's working with architects and designers and general contractors to understand the values of building with wood across the bioproduct. Again, like having those renewable fuel producers that want to lower the carbon intensity and what can be the input of bioenergy. And then really having that conversation at all levels of government around fire smart, but the forest sector can play a role in that climate smart forestry, which is really implemented at a landscape scale. So I'm finished. Happy to answer questions, and I'll stop sharing for now.
Great. Thanks so much, Kate and Sarah, for the really informative presentation. That was excellent. We do have about 10-12 minutes left for questions. So you're welcome to enter that into the Q&A box. There's also a few questions already that have been asked, and you can vote for them if you like it and want to see that question answered. So I guess we'll start off with the first question is, do these FPAC targets feed into provincial and/or federal GHG reporting, such as the federal LULUCF reporting?
Yeah, I can take that. So essentially, these are targets for ourselves as a sector. And what we'll do is we'll see them if we make improvements and lower emissions, we'll see those reflected in provincial and federal GHG reporting. So if our sector has a line item in the National Inventory Report on manufacturing. So if we implement these and we see emission reductions, because we report transparently to the government through NPRI reporting, then those emission reductions will be reflected in provincial and federal government. So I hope that answers your question. It's an internal kind of commitment or challenge for us, what's possible, but we rely on government inventory reporting of emissions to reflect those changes. And we want to be consistent with the government official reporting on GHG emissions for our sector. I can move to the second question, Suzanne.
Yeah,
Is FPAC claiming GHG reductions that are linked to land use of publicly owned land? And so I think similarly, well, one, we're not actually claiming any GHG reductions as a sector. These aren't formally kind of under for instance, a developed carbon project and offsets or anything like that, but rather, and as Sarah mentioned, we actually chose not to set a target for forests, just knowing that it's quite vulnerable as far as the significant amount of natural disturbance on the land base. We would, in time, like to get to the point where we would be like Nordic countries, where we are actually increasing the carbon stocks in the forest and demonstrating that climate smart forestry may be having a positive effect on emissions release of the forest. But at this point in time, our targets don't include forests, which are primarily on public land, but provinces will and the federal government will continue to report on LULUCF land use change in forestry according to the methodology they use. So I hope that answers those questions. Maybe I'll let Sarah do the slash burning one.
Sure. Yeah, the question is the slash burning double counted if it's both within the managed forest and forest sector operations? And the answer is yes, it is technically being double counted, but the intent of the emissions profile was not to like just sum up the emissions and the removals to get a net number at the end. And the reason that it's in the managed forest is because that is how, the number that is reported in Canada's National Inventory Report that we used to identify the carbon removed by the managed forest is rolled up into that number. And so we didn't want to deviate from that because we wanted to stay very transparent and aligned with Canada's National Forest carbon accounting methodologies. But then it was also, a really important opportunity for the forest sector to reduce those emissions. So we felt it important to highlight and call those out specifically. So that's why they're also under forest sector operations emissions.
great. Thanks. Okay, question from Bruce. Is hydrogen as an alternate fuel considered for heavy trucks within the future targets, recognizing the weight of batteries reduce payload greatly?
I can start, Sarah, but if you have additional information, it didn't come up as something to look at currently. I would say that if it becomes a viable option, we could include that in the future. I have limited understanding of hydrogen production. My understanding is that it still utilizes a fair bit of natural gas to create hydrogen produced electricity, but it's definitely a question that I can take back to our technical leads and see if it's something that becomes included in the future, if it's viable for adoption across the sector. Anything to add, Sarah?
No, that's
Okay, thanks. We actually have a question from Adrian in the chat box, and they ask, I'm curious if you know of any common misconceptions about climate smart forestry and wildfires that the public has that would be beneficial to address.
Yeah, I can start. Again, this is climate smart forestry is a concept that has more maturity, I would say, in Europe. It's a relatively new term in North America. We're seeing come up in the scientific literature. We're also seeing, for instance, one certification standard in North America has included it in the last revision of its standard. So SFI included climate smart and fire resistant forestry as indicators in its standard. So it has put together a set of recommendations for companies that are certified to that standard to implement. I would say and something that we've actually been promoting for some time is, so under the Canadian Council of Forest Ministers, there's guidance on undertaking vulnerability assessments within the forest. So most of our members have undertaken vulnerability assessments. And so that's understanding what, you know, as we do long-term forest management plans, what areas of the forest that you manage are most vulnerable to pest outbreaks or wildfire or drought or wind blowdown, whatever the disturbance might be. And then what are ways in which you can address those vulnerabilities? And so I think climate smart forestry is just one component of that. There are other ways, even just how you organize the timing of your operations, having some contingency built into your planning. So freeze thaw cycles are changing. So it really is that concept of adaptation and resiliency building. But it's starting to identify the real opportunities around what trees are most vulnerable. Is there an opportunity to change the sequence of harvesting to reduce the vulnerability to catastrophic fire? And are there opportunities to be planting more adapted silviculture techniques in the future? So there's a whole bucket of research happening in this space. But yeah, I don't know what the common misconceptions are. I think it is such a new term in North America. So we do need a bit of time to understand its applicability in the Canadian context, particularly given we're locked in, at least in the near term, to much more dramatic effects of climate change. And so what actions can we take in a timely manner that can make a difference? So I don't know if Sarah, if you have more
yeah,
to
I
add.
can I can add a bit in terms of like public misconceptions. So maybe thinking that climate smart forestry is a license to harvest more, and that that is not the case. In some scenarios, it makes sense to harvest more. Where wildfire is a greater risk and the stands are older and more vulnerable. But also noting that in other areas, conservation of old growth makes way more sense from a climate change mitigation potential. So, just like noting that it's very nuanced and very dependent on regional circumstances, and it's not a one size fits all approach that will be applied the same way across the country.
Adrian, if you're a member of the Forestry Adaptation Practitioners Network, I think that would be a really good question to pose to the online community. We all have members in Europe from Europe, so they might have some perspectives and some examples they could share with you. But great, thanks for those questions. Okay, we still have a couple more minutes, so we have one more question from Eric. What role does FPAC see in leading emission targets for industry companies? Slash pile burning is an area where companies could voluntarily provide better management with reduced emissions if they are willing to pay a higher cost for treatment. Who is accountable?
A great question. I would also encourage, actually, I'm presenting next week on ESG reporting in the forest product sector. So I actually was just doing my homework of across our members anyway, of publicly traded companies that have committed to emission reductions. So many are committed to SBTI, Science-Based Targets Initiative, or CPD, Carbon Disclosure Project. So they have put in place emission reduction targets, and some of those include reductions in slash burning. And so there would be more detail related in those companies' sustainability reports. But there's some amazing work happening, I would say, particularly in British Columbia around, for instance, the organization BC Forest Enhancement Society, which is really trying to reduce the amount of slash burning that's happening. And it's really around, I think as most people know, a lot of it is just the economic transportation of that fiber. And so if they can pair a slash pile location to an end use of that product, and so they're doing some great work in reducing. So there's more that can be done for sure. It really is, as I mentioned, it's really finding an economic home for some of that fiber. And there's commitment by companies to increase the utilization and to reduce the slash pile burning. But it's different in different locations, and those commitments vary, I would say, across Canada. So hope that helps, but it's a really excellent opportunity for increased utilization and to actually feed the bioeconomy.
That's perfect. So thanks everyone for joining us today. Really happy to have you all. I will be sending out a link to the recording, a copy of the presentation slides to all those who are pre-registered via email and to the Online Practitioners Network. Kate, Sarah, any last minute thoughts or remarks?
Thanks for the opportunity.
Yeah, thank you for the opportunity. We can share the report, a link to the report with Suzanne. And yeah, welcome any questions and feedback in the future.
Great. Okay. Enjoy the rest of your day, everyone, and we'll see you at the next event.
Thanks, Suzanne.